the increment and decrement buttons. So I'm going to, hopefully that was kind of enough to get everyone started and having code executing and doing stuff. So I'm going to turn you loose on the increment decrement button task for a few minutes. And when everyone feels like they've either succeeded at it or are ready to give up or whatever else, I'm going to come in and implement that for you, and you'll see how that works. Sure.
On the bottom half of your split panel, did you put the code that you just added?
Oh, sure. Yeah, of course. Actually, I'll put it up here because you all have tasks in your project. There you go. Sure. So, I'm to that laser pointer. Okay. So we're going to start over here with our existing cart on our existing model, right? We're then using map and first as our transformer function to take this cart model and turn it into a list of pets. So instead of being a list of tuples with pet on the left and an int on the right, this between the parentheses will just be a list of pets. Okay, so we're going to iterate through this cart, and each item of that cart is going to be transformed by first, which will just pull the pet out of the tuple, and that's all it's doing. So this will give us our list of pets, and now we can say list.member, our current pet, is that current pet in our list of pets. And we can fork there. And just to be clear, if we had not put this map here, if we just say model.cart, this is going to give us an error. And it's going to give us an error because one of our arguments is a pet, and the other one is a list of pet tuples. So it's expecting there to be a list of pets, but instead it's a list of pet and some number on the right, and that's not what we want. We can't do that. We can't say, hey, is this pet a member of a list that isn't a list of pets, right? We could say, is pet, comma 1 in our list of tuples of pet and item, but we can't just say pet. If we just say pet, that's a type error. Okay? Save? Yeah. I'm just saving the file. Okay. So you needed help. Okay, so refresh this. This is correct. Oh, you don't have that mouse. Yeah, you need a mouse. That's all it is. It's saying, oh, we're not. Everyone good? if you go to, everyone can go to packages.llang.org. That's the kind of package repo, and in there you'll see core. Go to core, that's the standard library that's accessible to users.
I should not joke. What did you say again? Packages that online?
Yeah, so
The wrong place.
this was in the, if you go to the resources markdown file in your project,
Oh, okay.
it's in there. So, yeah, go there. Go to place. We'll have all the standard API available to you.
Thank you.
Okay. And then one other thing to note that we just tripped on a little bit. In pattern matching in Elm, the tabs have to align. So if I do this, that's not going to work. Come on, projector's just dying on me. Awesome. Okay.
My code to do the update for increment and increment is going to be ugly. Is that expected?
Okay. Yeah.
No, I'm saying, to avoid the phrase.
We both just saw the map. We were writing the map.
Oh.
The helper was there.
Yeah, don't forget there is a helper function in this file, map when, that may help you in your quest.
That's pretty helpful. Yeah, that's all. mean, I'm not saying I was writing this for myself, but I might know someone who did.
Get wrecked. Cards not being wound.
Yeah, should you mind?
Wounds are.
Better than one plus doesn't work yet either. I'm still not.
Still working on it. No, what's wrong with it? Just like even looking at the complete flip chart. Same thing.
All right, so it seems like we've had quite a few people finish this one. So if anyone has not gotten it yet, you're about to see how to do it. So here we go. In our update function, the first thing we need to do is we need to handle that these are new message types, right? Increment and decrement are new actions being taken by the user. These are going to be new messages that flow through our system. We need to document them on our global universal message type of GUI happiness. So make one called. You can take it however you want. So we're going to increment, and if we just get an increment event through the system, we're not really going to know what we're supposed to be incrementing. So increment needs to take a value. We're going to take a pet as the value to increment. Okay? We also have a decrement action. And we need to know what pet we're decrementing there as well. So using the same pattern as add, we've added an increment message and a decrement message to our message type. Okay, and now update should be mad at us. And update should be mad at us because, hey, we don't know what to do with increment and decrement. So compile time error. So we need to go in here and add those nice things. So we're going to increment, and we get a pet by incrementing. And let's write the logic that will update our model such that whichever pet we found is going to increment in the model. So we have up here, I left a little helper function called mapWhen. MapWhen takes a function from int to int as its first argument. That will describe how we're going to do a thing. Let's also take a pet as a kind of like a predicate. We're going to say we're only going to perform this int-to-int transformation on a line item when the pets match. That's kind of what this mapWhen function is trying to do for us. And because we have currying, we can use this in kind of a nice, convenient way. So here we need to update whichever member of our cart contained the pet in question so that its quantity is been added by 1. So we'll say list.map because we're not really changing our model, we're just kind of modifying it. So we don't want to do anything too crazy, we're just going to do a map. And then we need to pass a function to map that's going to update in some reasonable way when the pets match. And so we have that up there with mapWhen. So I'm going to say mapWhen. And let's take a look at mapWhen again. So mapWhen takes our function and a pet. And so mapWhen will pass in our pet, or no, we'll pass in our function first. And so we'll do a lambda. Okay. Hold on. Okay, so we're going to do a lambda. So that's going to be our function from int to int. We're going to take an int and we're going to add 1 to it, which will give us a new int. And we're going to say we only want to do this when our pets match. And I'm going to leave it at that. And so what's inside the parentheses here, if you remember from the currying conversation, is very simply going to be a function from line item to line item. Because we've only given it 2 of the 3 things it needs. We've given it a function from int to int, we've given it a pet, but we have not given it a line item, right? And if you remember the type signature for map, map takes a function from A to B, a list of A's, and gives us a list of B's. And so since our cart is a list of line items, that should do it. And we should have increment. And so by using currying here, we've been able to kind of bake in our predicate. We'll map over our cart, which is a list of line items, and we'll apply this partially applied function from line item to each member of the cart. And so when the pets match, it will increment by 1, and when the pets don't match, it will do nothing, which is described up here. So pets match by 1. We're also clamping. Just note this. We're saying, hey, quantities cannot be less than 1 or greater than 25. That's just for the sake of the exercise. Okay? Sweet. And so let's save that. And ooh, we still have a type error, and that would be because we have not implemented decrement. So put in decrement. We're going to get our pet out of decrement. And man, this is going to be super similar, isn't it? So I'm going to copy paste this in flagrant disregard for dryness. And save that.
So that becomes a cart, but that doesn't become a model.
Oh, you're right. We are still wrong. So that's why it's not pattern. That's why it's not type checking. So, and actually, it says right there, it's on the bottom. First branch returns some record with an A on it, and a cart that has a list of pet ints. And our second branch returns a list of line items, and that's not what we want. So we need to go in here and make this slightly uglier. So we want our current model such that our cart is equal to all this nonsense. Okay. So there we go, that type check. So we're good. And that should be sufficient to get increment and decrement to affect our model. Okay? So let's see if it does. Oh, you're right. Decrementing really ought to be subtraction. That's really the difference and why dry code kind of is important. Yeah, if you care about that kind of thing. It's not giving me like a cursor where I want it to be. Holy crap, really? Okay, there we go. All right. Okay, and so if I refresh this, we should have the appropriate behavior. And we can add a Furby, and we can increment our Furby, and we can decrement it. Oh, that doesn't work.
Did you update the view?
I did not update the view. You are correct. That would explain why it doesn't work. So we're probably updating our model, but we're not actually firing increment and decrement events, considering we just added that to our message. So we need to go over to our view, and we need to go and find the place where the increment and decrement buttons exist. And there they are, and it looks like they're set up for us with no ops. So they're not doing anything, and when you really change this to be, this one really should be decrement. A decrement, and it should decrement our current pet. And this one really ought to be an increment,
Yeah, don't get those switched.
and we'll increment our current pet. And it wouldn't be so bad. It'll show up in our user testing. Okay. And that's it. So you can see kind of how easy that is to extend functionality to our app. When we need to extend some kind of a user intent, we add it to our message. We wire things into our view that send that message, and we change our update function to update the model appropriately. And that's really the pattern of using the Elm architecture in a core way. So we're updating these three values. Sure.
Can I ask another question? Why
Yeah.
doesn't it go negative?
The reason it doesn't go negative is the way I implemented map when has clamp inside it. And clamp says, hey, you're restricted to a number no less than 1 and no greater than 25. And that's just for the purposes of the exercise. We really shouldn't restrict it to 25. We should be restricting it to however many are in inventory or something.
Yeah.
But I think it's reasonable to clamp to 1. I don't really know how you would purchase negative Furbies. This void that can only be satisfied by the presence of a Furby is $5. Sure.
Looking at the beginner program record, which I passed to it seems like that could be redecomposed.
It seems like it. You might find a way to.
Is that a thing?
So you can compose records that look like that beginner program together. The thing is that when you're doing having subprograms and subcomponents and things that you're working with this way, generally speaking, you may or may not have all three. So if you remember the button component we wrote, it only had view, right? There was not an initial model or an update function with our button component. It only had view.
But you could like, I feel like the button could pass a simplified message of like click, and then the click could be translated into the real message, which is.
Yeah, so we'll get there. My point is that there might be a way to do it that way. There might be a nice, elegant way to do that. I haven't seen it yet. And usually I think the reason I'm not seeing that is because different components in the Elm architecture may or may not need all of those things. And they may need those things in different ways. And so forcing all of your subprograms to conform to a standard that would then work, you might be able to do that. I'm not seeing a whole lot of that in the wild because of the differences in the way different components operate. So we might have, for example, something that just knows how to update a model. We might have some piece of logic we want to reuse that just knows how to update a model in a certain way. Or we might have a piece of logic we want to reuse that just knows how to make a view. Right? Now, we will in this exercise, if we get to it in time, I don't know if we will, but if we get to it in time, we will wire in a drop-down component, and that drop-down component does have its own state. and you'll kind of see how that works. But yeah, if you can find a way to compose program records that's pleasant to use and works, I recommend you do that and release an open source package, because that'd be pretty cool. Okay. So there, we've implemented increment and decrement. Does everyone have that and understood kind of what happened and the pattern and how to do it? Okay, sweet. So moving on from that, if I can wrestle control of the mouse. Let's see what's next. Oh, calculating the total in the cart. So we want to display the total in the cart of what's currently in there, and I'll give everyone a few minutes to try that for yourself. The one hint I'm going to give you right now is that we don't need the total to be in the model. The total can be derived from the model as it is right now. So the update function is not the right place. I encountered some engineers who went straight for the update function as the place to calculate the total because, hey, that's where logic lives. But an update function is really where logic lives that affects the model. So for the purposes of this workshop, we're going to implement the total computation in the view layer.
Is there a list folder? Is there a list folders?
Yes, absolutely. And if you go to if you look in the resources markdown, it's got the standard lib, and you can see there's fold R and fold L.
I have two questions. Well, for this total thing, can you talk about how this HTML type works? And like I understand React, I don't know about virtual DOM, but
Everyone calculating totals to some degree, or feel like they could post this workshop? Yes, so in the module html.app, there is a map function which will do exactly that. I'm assuming you moved on to the drop-down component? Okay. That's the right track. That is in fact the right track, yes. Okay. All right, so let's see. What were we doing? We were calculating a total, I think. All right, so I left this nice little to-do for you to calculate the total. Let's go ahead and calculate the total together. Okay, so I'm going to calculate it differently than I did in the complete folder because I saw some of you were using the complete folder to do this, and this will be more interesting. So first thing that we're going to do is we're going to, let's see. So we have our model.price function, which is going to take pet and tell us what price it is, right? And we have, so let's imagine that we put a pet in there. And then we need to multiply that by whatever quantity was in there, right? So that's really what we need to do to get the cost of one line item. And so I'm going to write this in a strange way. So I'll pattern match on the input to a lambda to pull these out. Okay? And so that will give us our method to get pets and quantities, line items, into a total for that. And so what I'm going to do then is we'll say list.map. This lambda will be the function we pass to map. And then we will say model.cart. And that will give us a list containing, that will give us a list of floats, each one representing the subtotal for that line item. Does that make sense? But we need the total for the whole cart. So I'm going to just pipe this into another function, list.sum, which will just add those up for us. What is your problem? Ah, you're right. Quantity is an int, not a float. So we need to do to float. And there we go. And so there we've computed the total for our thing. And you know what? I think this code can be a little bit prettier with some help. So I'm going to use a very friendly notation to do this. And I'm going to take the cart because auto currying. And I'm going to pass that, I'm going to pass that up at the top. Indentation's not being my friend. Okay, and so that worked out just fine. What this is going to do is it's going to take our model.cart. It's going to pass it into our first function, which is a partially applied map function with this lambda inside it. It's going to take the result of that map function, which is going to be a list of floats, and we're going to take that result and pipe it into list.sum. And so this gives us kind of a nicer, more sequential, imperative way of thinking about this while still being very nice and purely functional. So we're just going down this chain, and this is something that you should aspire to do. That makes code very easy to read and very easy to understand. Okay, and so with that, that should work, and we should get a total. All right, so we can add some Furbies. We can write the quantity, and the total goes up, total goes down. We're in good shape. And so the last part of this was the part that really made this a 101.5, which is wiring in a component. So we have this drop-down component that will do that, but we are in the last 5 minutes of the workshop, so I'll just open it up to questions. No, I will finish the slides, and then we'll open up to questions. So that makes slightly more sense, I think. Could make more sense.
Really?
Really?